So let's make some rocket engines using kids glue. So let me explain here a little bit, some information. I plan on using the A.P.C.P model to test to see if this is even possible. And I don't know. I'm going to try it because I have an inkling that it will, but I don't know. The A.P.C.P model is ammonium perchlorate composite propellant. A.P.C.P includes ammonium perchlorate, aluminum powder, and traditionally polybutadiene or polyvinyl chloride, which we know as PVC. Using the traditional or well-known A.P.C.P mix, the AP, ammonium perchlorate, is the oxidizer, the aluminum is the fuel, and the PVC is both the binder and fuel. I did a video just over a year ago where I used the A.P.C.P model and I used ammonium perchlorate, aluminum, and silicone in place of the PVC, and this produced a very powerful rocket engine, and plus it was continually waterproof because of the silicone, kind of a side effect of that. What I plan on doing this time is removing the silicone, so we will be using the ammonium perchlorate, the aluminum, but using the kids glue in place of the silicone. And this is the kids glue I'm talking about. It's Elmer's washable school glue, and you can see it's the stuff you smear on paper and then stick another piece of paper to it, etc. For kids, it's non-toxic, but that's the stuff I'll be using in place of the silicone. My plan is to test different ratios, and I'll possibly be starting, and I should say probably, with data from using the silicone. This gave me a good idea of what mixes produce what kind of thrust, and without anything else to go by, because I'm doing this from scratch, that's probably what I'm going to start with. Interestingly, I learned that kids' glue sticks, the ones we just looked at, are made up of 95% plus polyvinyl acetate. So you write that out as PBAC, and PVC is polyvinyl chlorine. These two are obviously very different in the end product, but they both are polyvinyl. So there is something there chemically that is similar. The biggest difference is that polyvinyl acetate is non-toxic and biodegradable, whereas the PVC and the silicone are not. Also, when this burns, it produces pretty much non-toxic products, but PVC and silicone, when they burn, say inside of these engines, they produce a lot of harmful byproducts. So there's a good side of doing this PBAC stuff. I'm not sure how it's going to work, but if it works, it's definitely a healthier, safer way to make these engines. I wanted to show you also the vinyl acetate as a single short molecule is CH2 double bonded to a carbon, hydrogen, oxygen, carbon, oxygen, and then a CH3, whereas the vinyl chloride is very short. It's just CH2 double bonded to a carbon and then HCl. Moving on to our materials, we'll need ammonium perchlorate, aluminum powder, Elmer's kids glue. We'll need something to make the nozzle out of, tubing to put everything in, and a fuse to light it. I did research the reactions, and these are pretty general reactions. I couldn't come up with specifics because there really wasn't anything online about making a PVAC, polyvinyl acetate, rocket engine. So this is the best I could come up with. Using PVC, there were PVC, C2H3Cl, that is actually the same as this up here, plus oxygen. So when you burn PVC, you get carbon dioxide, water, hydrochloric acid, and heat. When doing the overall reaction using PVC, you have 6 of the ammonium perchlorate plus 10 aluminums plus a chain of the PVC, which is C2H3Cln, which will give you aluminum oxide, carbon dioxide, water, hydrochloric acid, and nitrogen gas. Moving on to using polyvinyl acetate, the C4H6O2 is the same as this right here. It's just shortened. So if you take 2 of those plus 9 oxygens, and you have to continually apply heat to this. So this is absorbing heat. This gave it off, but this will not burn on its own very well. But if you can get it to burn and continue to burn in its dry form, you'll give off 8 carbon dioxides and 6 waters. Just to note that when we're using the polyvinyl acetate or this kids glue, I'll be using it wet initially to make the mix and get everything mixed up good with the aluminum powder and the AP up here. But when it burns later on in the engine, as part of the engine, it's going to be dry. So we will get these products out of the PVAC as part of this rocket engine. So the overall simplified reaction for using the PVAC, or the kids glue, is 6 ammonium perchlorate plus 10 aluminums plus C4H6O2, which is the PBACN in a chain, will give you 5 aluminum oxides, 12 carbon dioxides, 9 waters, 6 hydrochloric acids, and 3 nitrogens. What's pretty interesting about these reactions, the PVC reaction and the kids glue reaction, is that we're putting in the same molar amounts of ammonium perchlorate and also aluminum, 6, 6, 10, and 10. But as far as products being produced, both the solid aluminum oxide and the gases being produced here, there is quite a bit more coming off of the PBAC than the PVC. I'm not sure what that means, if that will translate into real-time changes in thrust or better thrust, but it's just something to note on these reactions on paper. And lastly, the methods. Super basic. We're going to mix the AP, aluminum, and KG now stands for kids glue in varied ratios. I'm going to test these to determine the best ratio or best ratios. Then we're going to put those best ratio mixes in tubes, make nozzles, and light them and launch them. I said it was really basic. All right, let's go give this a try and see what happens. As I mentioned, these are the only 3 ingredients we need. Here's our ammonium perchlorate, 400 micrograms, our aluminum powder, 5 micrograms, and I'm really blessed to have this at such a fine level because that makes the biggest difference really is how fine your aluminum is. And last but not least, Elmer's Kids Glue. I'm going to use this craft tube right here. It's cheap, it's kind of small, which is great. You don't use a lot of ingredients. Ammonium perchlorate is not always easy to get a hold of. So this is what I'll start with when we actually test the rocket engines. I made this really basic table here as a guide to follow as we go along here. The numbers I used here I took from the previous video I did when I was doing ammonium perchlorate and aluminum and silicone. So I'm starting with some of the same ones because I really don't know where else to start from, to be perfectly honest. But so you can see right here our materials: ammonium perchlorate, aluminum, and kids glue. So the first trial is going to be 7 grams of ammonium perchlorate, 2 grams of aluminum, and 4 grams of kids glue. And then I'm going to try that not as a rocket engine, but I'm just going to kind of smear it in a line on a piece of paper and light it just to see how fast it burns. And then I'm going to do the second trial here, 723, and then you can see 722, 733, and then 732. Now out of these, whatever turns out to be the 2 best ones, I'm going to start working with those small rocket engines. 7 grams of ammonium perchlorate, pre-weighed. 2 grams of powdered aluminum, pre-weighed. 4 grams of wet Elmer's Kids Glue, pre-weighed. I moved those 4 grams of kids glue here, and I've got to kind of mash this stuff up first before I start mixing in the AP and aluminum. First, I'm going to add the ammonium perchlorate, the 7 grams, and work this in slowly. Next, the aluminum. Here you have it, maybe the very first rocket engine made with kids glue, but that's not the important part. I just want to see if it works. That's the most important. So, all right, what I'm going to do now is transfer this to a 3x5 card and kind of string it out like I said so we can test. Here's a 3x5 card I was talking about, and I did my very best at stretching this out. This is very wet and gooey, and yeah, it's going to take a bit to dry, but I'll stick a fuse in here for safety's sake. So when we light it, I can just light the end of that fuse right there. But when it dries, I'll be back and we'll light it. It's been 28 hours since I first made this. After 24 hours, I cut the very tip of it off right here, like that, just to see if it had dried or not, and it had not dried. It was super gooey down deep. So I cut these lines right here, and I put it by a fan. So in the last 3 hours, it's been drying by a fan, and I really believe it's dry now. It's pretty darn hard, but it is soft. You can see these holes I poked here. If I take this sharp dowel, you can see it easily pokes into this stuff. This glue was made to put, wipe a thin layer on and then maybe glue another piece of paper or whatever. And so it's not meant to be thick like this. So I have a suspicion that it's never going to completely dry, or dry hard, I should say, which is actually good, meaning it will be moldable for quite a while. The downside is it might take a long time for it to dry in a tube for a rocket engine. Regardless, I'm going to go test this as it is right now. Let's see if this even burns. Oh wow. Oh yes. Holy smokes. Oh my goodness. That was so impressive, actually. I did not expect that. The second trial here is, again, 7 grams of ammonium perchlorate, 2 of aluminum, and the kids glue drops by a full gram. 7 grams of ammonium perchlorate, pre-weighed. 2 grams of powdered aluminum, pre-weighed. 3 grams of kids glue, pre-weighed. You can see the difference here between a tube that has been open for a couple of days and a brand new tube, which is the darker purple. That colorant is put in there so when kids use it, they can see where they're putting it, and it disappears from the oxygen in the atmosphere. But you'll notice when I mix in the ammonium perchlorate, that colorant disappears immediately out of the glue because, of course, the ammonium perchlorate is oxygenizing the colorant, and therefore it goes away. Smashing the glue down. Adding the AP. Adding the aluminum. Once again, I'm going to put this on a separate 3x5 card to clean it up a little bit. And I kind of decided if I have too much, I'm just not going to use it, because to wait for it to dry, unnecessarily just for a test is kind of silly. So I'll be back when I'm done with that. I was about to transfer this to that 3x5 card when I had kind of a eureka moment. And what I decided to do was smear out what you just saw really thin I put it by a space heater for about 30 minutes, and it is almost completely, well, no, it's at least 50% dry. It's still a little tacky in some spots, but my goodness, it's so much better than it was. I suspect this took off maybe 20 hours of drying, and I'm not exaggerating. So that is the way I'm going to do it from now on. Now that it's drier, I'm going to transfer it. Transferring this rocket mix was so much easier now that the glue was partially dried. I still cut the slit down the middle because my whole goal here is to dry this stuff as fast as possible so it can be tested quickly. At least that's from my perspective. There is less, it looks like there's less because there's a whole gram less of glue, which should also help the drying. So I'm going to dry this up and we'll test it. I left it by just a fan for another 2 hours and it's completely dried. Again, really nice. I did see it burn definitely quicker than last time from one end to the other. As the glue is what is burning as fuel in these, it is nice that less glue means it dries quicker, but I'm wondering if the lower amount of fuel to burn is going to affect these very much. I might not actually find out till I do the rocket engines. We'll see. All right, let's light it. Oh wow, yeah, that was incredibly quick. My goodness. That was so good. I'm still going to do the other two, but that is looking like a plus for sure. This is the first test where the added aluminum changed the ratio of the AP to the aluminum. So let's see what happens. Well, it burns with a really steady stream there. Not as fast as the last one for sure. Not surprisingly, this was the easiest one to transfer. It was very moldable, so when it dries, we'll light it. Kind of looks like a rocket. Trial number 5. It actually launched itself off the piece of 3x5 card and burned so nice and smooth. Well, I gotta say, I think that's the top runner right now. When going back and reviewing each of the burns, I looked at trial 3 and trial 5, which we just did, as the two I commented on the most and what looked the best. So those are the two I'm going to go with. Interestingly, those are the only two with only 2 grams of the glue. So that's a kind of a downside, because when it comes to the volume of making engines, you don't want to go through your AP and aluminum as much compared to the kids glue, but it looks like that's going to be the case. And we're going to go with what I think is the best. Trial 3 and trial 5. We're finally at the making the rocket engine part. So I plan on using these tubes right here that I mentioned earlier. They're a 1/2 inch diameter, and I found that, of course, drying the mix first is the best way. So a partially dried mix will get stuffed in here. I'll leave at least a third for a nozzle, because these engines are so small. If you don't do that, you're going to have such a weak nozzle, it'll get blown out easily. So 2/3 filled with dried mix, and then I plan on using a 1/8 inch dowel. I'm not going to drill this through, and just pushing it through the engine and allowing it to dry mostly, and then I plan on removing that dowel before it completely dries. That hole right there is put there for several reasons, and they are listed right here. The through hole allows the dispersion of the exhaust products easily through that hole. I've had many instances where without this hole, in testing a rocket engine, some partially burned mixes or exhaust products come up and get stuck in the nozzle, and they'll go up maybe 20-30 feet and blow up. So you don't want that. It just allows the exhaust products to get through. It also improves the drying, which is important for this. Obviously, if you're drying from the center and from the outside, it's going to dry quicker, and it improves the specific impulse. So we have removed the 1/8 inch dowel, going to let it dry, of course, completely. Then I plan on reinserting the dowel when it's dry, like I said, and then pack the nozzle material, which I usually use a mix of kitty litter and some epoxies. It works great, and I've used it for a lot of rocket engines. And I'll just stuff that around the dowel here, and then I'll remove the dowel before it dries, and then let the whole thing dry. And we'll have a 1/8 inch hole all the way through the nozzle and through the material. Also, the fuse is 1/8 inch wide, which works great when you're launching these, because using electric igniters gets very tedious when you're just testing one engine after another. So here's the 722 mix, 7 grams of ammonium perchlorate, 2 grams of aluminum, and 2 grams of kids glue. Now, when this is done drying here, I won't be transferring it to another 3x5 card, of course. I'll be transferring it to this tube I was talking about. So I cut these at 3 inches length, which might be actually too much for the volume right there, but you know, we're kind of making things up as we go. So once this is packed in here and I have a hole pushed through it, we'll figure out how deep that is and then add a third for the actual nozzle. I built this jig just to make it easier to put the material inside of this tube here. Piece of wood, couple scrap pieces of cork that I glued, and then just drilled a 1/2 inch hole right through there. It's been about a half hour since this dried, and it's just about right. So I'm going to start putting that inside the tube there. Well, looks can be deceiving. I actually had more material than I needed. I marked this about 1 inch down here for the nozzle, and I've reached that point right now. So I'm going to push a 1/8 inch dowel right here through it, like I mentioned, and then we'll let it dry, and then we'll work on the nozzle material. I can feel the point of the dowel as it came through there, so it goes all the way through. Doesn't really show on this end here, but there's a nice 1/8 inch hole right through the center like that. So let it dry up, like I said, and then we'll do the nozzle. Now that this engine has dried through and through, it's time to make the nozzle. I mentioned earlier I use usually an epoxy mixed with kitty litter. This is JB Quick, which works just as well as other epoxies. This JB product does have metal in the actual mix, so that's one of the reasons I tend to use this. And this is kitty litter, which is something that just does not burn. So the combination makes a very resistant nozzle. And once it dries rock hard, so you can drill it. But this time, as I mentioned earlier, I'm going to use the 1/8 inch dowel rod to make the opening. But first, let's mix this together. I have the engine there with the 1/8 inch dowel, and I'm just going to start stuffing this around the edges. It's a little tedious. It's going to take a bit. Because it is JB Quick, it sets up in less than 10 minutes typically. So I'm going to just rotate this and get it out of here. And there we go. We have a nice 1/8 inch nozzle. It's a little messy looking, but that really doesn't matter. This is somewhat of a test engine still, but even if it wasn't, that would still work fine. I'll wait till this dries up a bit, and then we'll put it into the second tube for testing the 732 mix. This engine is packed with material, and I pushed a 1/8 inch hole right there. You can see, didn't think I needed to say much there. And once this is dried up in here, we'll put a nozzle on this one. Finished up the rocket engine of the second of the 2 best mixes, and that was the 732. I think this was originally trial 5. 7 grams of ammonium perchlorate, 3 grams of aluminum, and 2 grams of kids glue. So I'll put the nozzle on there right like so, and I'll wait until that hardens up, and then we'll launch it. I finished both rocket engines and taped dowels to them and put fuses in them. The only difference is the nozzles were a little junky looking, so I just sanded them down to make them look a little nicer. But these were the 2 best mixes that we tested earlier on, the 722 mix and the 732 mix. So let's give them a try and see what happens. Going in order, the first one up is the 722 mix. Let's see what happens. That was most interesting. Well, it wasn't a nozzle problem. That held up just fine. So, yeah, well, let's try the next one. Second 732. Well, there's the answer right there. It obviously worked. But fret not, as I made those test mixes early on, I saved a little bit of all of them. And so this is a 732 mix. I'm hoping this does it. And since it's kind of small, like a bottle rocket, it gets a bottle. All right, that was actually the rocket up there. I followed what popped down here.